In this video, I'm going to address the North Carolina Standard 8EE8, analyze and solve a system of two linear equations in two variables in slope-intercept form. This bullet at the top is the first half of the standard, and I think that it's really explained well in the unpacking guide. So let's look at the two bullets from the unpacking guide. Students are supposed to be able to explain and demonstrate that the solution to the system of equations must be a solution to each of the individual equations in the system. In addition, students are supposed to be able to compare the graphs and the equations in the system and understand when the system's going to produce no solution, one solution, or an infinite number of solutions. This is the second part of 8EE8, so this is the second bullet. And again, I think it's explained well with the unpacking guide. So the first bullet says that students are supposed to be able to write a system of equations to represent a word problem. We're going to do that. And then the word problems, how they're written, they have to be presented in a way that students can write the equation in slope-intercept form. So that's how the word problem is in this video. And then also students are supposed to be able to recognize the structure of equations, and just by looking at them, think about whether they'll produce one solution, no solution, or infinitely many solutions. So hopefully with all the different representations that we look at with the graphs and the tables and the equations, that students will really get a hang of what they're looking at and recognize it as one solution, no solution, or infinitely many solutions. This is an example pulled from the unpacking guide for standard 8EE8. In the example, there are two different plants, and they start at different heights and they grow at different rates. So they have different y-intercepts and different slopes, and students are supposed to be able to create a table, plot a graph, find the point of intersection, and explain what it means in context. They're supposed to be able to write an equation, and these are the sorts of things that we're going to do in this video with another real-world problem. The focus of this video is on a system that has no solution, and we're going to look at a story problem, we're going to look at equations, we're going to look at tables, and we're going to take a look at graphs to get a deeper understanding of a system that has no solution. Our real-world example is going to be a price comparison. So in class, I would have students make a decision, if you were going to get a puppy and you had to choose between a German Shepherd and a Golden Retriever, which would you pick? And have them make an upfront choice, and then we would start to dive into the math behind it. And we would start brainstorming about the costs of owning a dog. Now, there are 8 hexagons here, but of course we would fill in the whole page. That's just supposed to bring some color to the page and get kids excited. So we'd fill in some information there, and then I would show them my pictures and see if they thought of some of the things that I thought of, and make sure we did a good job with our ideas of what we would have to pay for if we purchased a dog. So I have here on the left, I would show them the dog crate, and then over here, did they think of a collar and a leash? Did they think about dog bowls and food, buying food? Maybe you would buy your dog toys and, vet visits. Those are some things that I thought about. Now, I would tell them that we're not going to be considering every single thing that you'd have to pay for the dog, but I just chose some different things that most people would be purchasing for their dog. And in the white writing is the upfront costs, and then in the black writing is what you would pay per month. So we have things like the purchase price of the German Shepherd and the purchase price of the Golden Retriever. And these were just prices that I looked up online. Now, depending on what state you're in and what breeder you go to, you might get a price that is slightly different than this. You might be able to wheel and deal and bargain with someone that you're getting the dog from, but these were some prices that I found online for these dogs. I chose the same price for the collar and the leash, because when I looked up golden retrievers and German shepherds, they were similar in their weights. So I thought, these dogs are pretty similar in size, so they're gonna have, probably the same size dog bowls, and they're both gonna need a large dog crate. And I also estimated the initial vet visits for like shots and things like that to be about $120. And then I have here for the German Shepherd, the price for 1 month of food, 30 days, $67.50. And then I have the price for 10 days of dog food for the Golden Retriever, $22.50. And then together we would come up with an equation for the German Shepherd and for the Golden Retriever for the total cost of owning this dog. And what I would do with my students is I would use Google Docs, actually Google Spreadsheet, to come up with our equation. This is the spreadsheet that I created for the cost of owning the dogs. I have on the left the prices for the German Shepherd, and then on the right, the prices for the Golden Retriever. And you'll notice that this is set up just like that PowerPoint slide. It's the same information. And then I would show to students things like down here, you can see that the price for 1 month, it cuts off, the words are cut off. So I'd show them to go up to formatting, and I could choose to wrap the text. So now it displays all the information. The price for 1 month or 30 days of dog food is $67.50. The same thing happened over here where it was cut off, and maybe I'd show them a different skill where they could click on the end of the column, double click, and then it would extend the cell so that you could see all of the words. So right there you're showing them some things on a Google spreadsheet. The next thing I would talk to students about is the fact that our upfront costs are going to be our y-intercept. So we need to come up with a total for our upfront costs, our one-time fees, the collection of them. So the next skill I would show students, so you want to show them a little bit about technology, is that on a Google spreadsheet or on an Excel workbook, you can create an equation which basically makes a spreadsheet similar to a calculator. And to start the equation, you start with an equal sign. And so I'm going to start with an equal sign. I'm going to type in $900 for the purchase price of the German Shepherd. And then I'm going to put an addition sign, and I'm going to add the $14.89 and then the $11.04 for the dog bowls, and then the $105.99 and the $120 for the initial vet visits. And then I'm going to press enter, and it's going to come up with my sum. And there's different ways to do this, but I would focus on, I'm just going to keep it simple because a lot of the kids haven't seen very much information when it comes to how to use a spreadsheet. Now, I've added this up before, so I can tell that I made a mistake somewhere. So what I'm going to do is I would in class click on this again, press enter, and show kids that you could look back at the information to check your work. So $900 for the purchase price of the German Shepherd, that's right. $14.89, yes. $11.04, that looks good. Oh, the large dog crate was $105.99, and I typed in $15.99. So I made a quick correction, press enter. Okay, that looks much better. I'm going to do the same thing over here. What do we start with when we write an equation in a spreadsheet? We start with an equal sign, and I'm going to type in now the $1,500 for the purchase price of the dog, $14.89 for the collar and leash, $11.04 for the dog bowls, and I have an addition sign in between each one of these prices. And then last, the $120 for the initial vet visits. And that comes out to be a total of $1,751.92 for the Golden Retriever upfront costs. And then we're going to come down to this equation in slope-intercept form, and I defined y as the total cost and x as the number of months. So we're going to write the German Shepherd equation, and the slope, or the amount that you have to pay every single month, is going to be the dog food. So every month you're going to pay $67.50 for dog food for this German Shepherd. So that's going to be your slope. So $67.50, and it's per month. And remember, X represents the number of months. And then we tack onto that the y-intercept, which is, the starting amount that we had to pay, or you could say the initial fee, the upfront cost. And the initial fee or upfront cost is $1,151.92, because that's for buying all these items that you just purchased right away. You purchased the dog, the collar and the leash, the dog bowls, the large dog crate. Right away, you got to take that dog to the vet to get shots and things, get it checked out. So that's going to be the y-intercept. So there's our equation for the German Shepherd. Then we're going to come over here to the Golden Retriever, and the upfront costs are $1,751.92. It's going to be the y-intercept. So I'll type that in. And then we need the amount per month. Now, up here it does not say the amount that we're going to pay per month. It says price for 10 days of dog food. Now, if we're defining month as 30 days, and we have the price for 10 days, we can pretty easily figure out how much it's going to cost per month. 10, or I should say 30, is a factor of 10, so we can just take 10 and multiply it by 3 to get 30 days. So we could also take the $22.50 and multiply it by 3 to get the price of the dog food per month. So again, we're going to show how to use an equation, and I'm going to type in equals $22.50. You use an asterisk for the multiplication sign, and then we multiply that by 3. And it comes out to be $67.50. So the same slope as we have in the other equation. And remember, these dogs are similar in their how much they weigh, so that kind of makes sense that they probably eat about the same amount of food, approximately. So we have our two equations, and we want to notice that the y-intercepts are different, but the slopes are the same. Now I'm going to take these equations and place them into Desmos to create a graph. So I just moved over the German Shepherd equation. Now I'm going to take the Golden Retriever equation and put that second. And then I'm going to go over to the tools over here, and I'm going to add a label for the x-axis. So x represents the number of months that you have the dog, and then the y-axis represents the total cost. And then from there, on the x-axis, if this represents the number of months, I want to go from, let's start at 0, and let's go up to, I don't know, 24 months, so 2 years of owning the dog. And then on the y-axis, if you think about it for the y-axis, we're going to need to go up to, thousands, because we're already, you'll see starting over here that the German Shepherd up front is going to cost us about $1,100. The Golden Retriever up front about $1,700. So I don't know, let's go up to $8,000 and see how that serves us. And then I'm going to unclick that and move my graph around a little bit, and you'll see the starting points here. So at 0 months, so right up front when you're purchasing the dog, the red line is the German Shepherd, because the German Shepherd costs less to purchase. So about $1,100. And then up here at month 0, so this point, well, let's see if I can get that point. So this point represents 0 months, and then it costs us about $1,700 to own the Golden Retriever right away. Then, this is at the 12-month point, And I found that I have trouble clicking on exactly 12 months. So what I like to do is I like to go over here and I just type in x equals 12. So I create a line at 12 months. So after a year of owning the dog, let's see, for the German Shepherd, you'll have spent about, $1,900 or so. And then for when you own the Golden Retriever, you have spent about $2,500 after a year. It's a lot of money. And then, if you look along this graph, you can see that they are the same distance apart. And the reason that they're the same distance apart is that the slopes of these two lines are the same. They both, we're spending $67.50 per month for the dog food, and the only difference is the difference in the original initial cost. So if that's the only difference in price and they're increasing by the same amount, like what you pay each month is the same, then they're never going to intersect. So it's always going to be the same difference in price. And if you look, you can pretty clearly see that, the 92 cents is the same, the 92 cents is the same. If you're trying to compare, really the hundreds place is the only difference. So the difference between the German Shepherd and the Golden Retriever is $600, and that difference of $600 is always going to be the same. So that's what it looks like when you graph them on Desmos. Since we have looked at the graphical representation, I would like for us now to look at the algebraic representation. I'm going to start by posing a question. For what x values are the y values equal? I think this is a good question to use when you're solving equations. That's what we're doing. We're looking for the x values where the y values are equal. I'm also going to pose this question in terms of this particular context. So here's the next question. For what number of months will the total cost of the dogs be equal? So remember, total cost is the y value. And I'm going to label this y value as y1, and I'm going to label this y value as y2. And basically, we're trying to figure out where y1 is equal to y2. So where are the y values equivalent? And if y1 is equal to this expression, then I can go ahead and replace y1 with that expression. And if y2 is equal to this expression, then I can replace y2 with this expression. And then I'm going to solve this algebraically. Solve for where the y values are equal. So I'm going to start by subtracting 67.5x from each side. And you'll see that we end up with two constant values that are not the same. Some people would go even further to make it look more simplistic and subtract the same value from each side, and we end up with 0 is equal to 600. So there is no solution to this equation. We know that there's no solution because 0 is not equal to 600. And also, when the variable disappears, basically we make 0 pairs on both sides, and you're just left with numbers, we know that that means we're either going to have no solution or infinitely many solutions. And if they're not equivalent, then that means that there's no solution. So this is what it looks like when you solve this word problem algebraically. It is time to create tables using these equations. What I'm going to do is I'm going to pull the expression for the German Shepherd, and I'm going to place that into Desmos. So I'll create a table, and then where it says y1, I'm going to go ahead and paste that expression. I need to, if this is labeled as x subscript 1, I need to put a 1 in here, a subscript of 1, and then I'm going to go ahead and fill in month 0 to all the way to 12. And so that will represent months 0 to 12 for a German Shepherd. And then I'm going to go over to this column and I'm going to pull the expression from the Golden Retriever equation and place that in this column. And once again, I want to use these same x values that I had chosen, so I'm going to make that a subscript of 1. And then you can do a comparison between the price of the German Shepherd and the price of the Golden Retriever, which is the purple. Maybe you want to look at some specific months. So after, half a year, 6 months, the German Shepherd's going to cost you about $1,500 and the Golden Retriever $2,100. Maybe you want to look at after a year and compare the prices of the two dogs. I think it's also interesting to think about how much it's going to cost you to own the dogs for the lifespan of the dog. So what I did is I pulled up the lifespan of a Golden Retriever on average and the lifespan of a German Shepherd on average. And, the middle value for the Golden Retriever lifespan would be 11 years. And you could have a German Shepherd that lives for 11 years. So I'm going to use 11 years. Let's say that your dogs live for 11 years. So I'm going to go back to the spreadsheet. I'm going to use it like a calculator and I'm going to write an equation. And what I want to do is I want to say that the dogs are going to live for 11 years. And remember, we're going to need to multiply that. Multiply by the number of months in a year to get the total number of months that we own the dogs. So to start an equation, we write an equal sign. And then I'm going to type in 11 years, and I'm going to multiply that by the number of months in a year. So that means that if each dog lived for 11 years, that means you would be taking care of the dogs for 132 months. So let's go back to the table and let's say that you own the dogs for 132 months. If the dog lived for 11 years, based upon the prices that we were considering, the German Shepherd would cost you about $10,000 and the Golden Retriever almost $11,000. I think that kids would be kind of surprised that it was that much money. And this is a low estimate because we only included vet costs in our initial fees, but there's going to be more veterinary visits over the years that you have your dog. And there's going to be other expenses like that we didn't think of. Maybe you're going to have a license for your dog, or maybe you're going to make tags for your dog in case your dog gets lost. Or, most people buy like a fluffy dog bed for their dog and toys for their dog. And, I don't know all the expenses that you would have for your dog, but those are some expenses you might have. And so I think this is a pretty low estimate. You might spend $15,000 on your dog or $20,000, or I've seen estimates online of it being $30,000 to own a dog for the lifespan of the dog. So this would bring an interesting conversation to the table when you're comparing the two dogs to put in, the number of months that you would own the dog. You might also want to have students be thinking about the differences in the table. So for example, we already in another part of this video found the difference between this initial value and this initial value is $600. But you could show that throughout, if you take this number, 2021.92 minus 1421.92, the difference is still going to be 600. And it's going to remain the same difference in price because the two slopes are the same in the equations. So that's something else for students to realize because they need to get used to the idea of looking at, well, if you're looking for a point of intersection, you want to see where the two tables are coming closer together. So maybe one is getting larger and maybe one is decreasing and then they'll intersect. Or maybe one starts off at a lower amount but its slope is greater, and so eventually, since its rate of increase is greater, it's going to overtake the other equation. So those are things to talk about when you're looking at the table with your students. At this point, we have looked at multiple representations for a system of equations that has no solution. We looked at a word problem. We looked at this algebraically, what it looks like when you solve it and you get two numbers that are not equivalent, that means no solution. We looked at it graphically. We're going to see parallel lines, two lines that do not intersect because they have the same slope and just different y-intercepts. We looked at the tables, and again, we noted that they're never going to have the same y values because they're always going to be separated by $600. So we looked at these different forms, and hopefully that gives students a better understanding, a whole understanding of what it means for a set of equations to have no solution. So this video covered the North Carolina Standard 8EE8. We're going to finish by looking at the vertical progression. So we're going to look back to 6th grade and see how we got to where we are with 8EE8. In 6th grade, students had to use substitution to determine whether a given number in a specified set made an equation true. So basically they take a number, plug it in, see if it makes the equation true. They also had to use variables to represent numbers and write expressions. In 7th grade, they step it up, and they're not only writing expressions, they're writing equations and inequalities. And it's real-world examples, just like we did today. And then I also put in here 8EE7 because I think that ties so closely to 8EE8. In 8EE7, so 8th grade standard, they had to recognize equations that are going to give them one solution, infinitely many solutions, or no solution. And then they also have to, solve equations and inequalities. And that brings us to Math 1. And in Math 1, there's so many, I feel like that 8E8 is going to help them with. So they're going to be moving on next to, I just chose 3 that I thought most applied. So this first one talks about how they're going to have to not only create equations that are linear, but they're going to have to move on to Math 1 to create equations that are exponential and quadratic, so writing equations and inequalities. And then they have to solve systems of equations. This part is talking about linear equations using all different methods. And then in Math 1, they also have to build an understanding of why the x-coordinates of the points where the graphs of two linear, exponential, or quadratic equations intersect are the solutions of the equation. So they're looking at solutions to not only linear equations, but what it looks like when you have, maybe no solution and you have a set of exponential equations, or maybe an exponential equation and a linear equation. So we're expanding this idea of systems of equations to other types of equations besides just linear equations. So hopefully that helps you with understanding what came before the standard and what comes after the standard.